Fafansy Slime is a game with the theme of endless running, in which the player controls the character Slime and then progresses along an endless path, avoiding various obstacles and collecting as many points as possible to collectibles and obtain higher scores. The difference between Fafansy Slime and the regular scooters is that on the one hand, Fafansy Slime changes the 3 forward tracks of the regular scooters to the left, top and right 3 tracks, and adds a sensitivity judgment to the jumping mechanism, which can control the height of the character's jump by pressing the jump button. For the time. In addition, there are also part of the random mechanism of gameplay. These new gameplay makes the game's levels have more playability and maneuverability. This game is always going to surprise you. This video will give you an introduction with the game. First of all, this is the main screen. You can see the background story, the teaching and teaching levels, the scoring function, the storage and reading function. So let's skip the tutorial and go straight to the game. You can see that the upper left corner of the UI shows the skills that the player can use and the item cards that can be consumed. In the middle is the game acceleration countdown. The speed of the player will get faster with each acceleration, and the upper right corner shows the distance the player has moved and the score he has obtained. These points can be earned by picking up stars and moons in the game. The lower left corner shows the character's HP. When HP hits 0, the game ends. Game can be saved when you stop it and click the save game. You can see that there are various obstacles of different heights in the level, and the player needs to avoid them in different directions or manage the height of his jump to get through them. At the end of the game, you can see that the score of this game is 76. The game also designed a mobile demo. What you see now is some contents in the mobile terminal. I'll talk about the details below. Then I will go through the order of must do, should do and could do in ICA to introduce the design of the function respectively. As shown in the previous video, it should be emphasized that in the game we designed the acceleration countdown of 30 seconds. You can see the countdown on the top of the game. To have 3 types of pickup. The 3 pickup are the blue star, pick him up for 1 point, the yellow moon, pick him up for 10 points, and there is an invincible card, use him to make the character invincible. 3 have at least 2 NPC or enemies. They are the blue monster and the red dragon, in addition to the blue imp moving around the game and the red dragon launching fire attacks throughout the game. You can also kill enemies by pressing the space, and kill enemies with a certain chance to earn item cards. For have control scheme and UI. This has already implemented in the game. Number 5 is score and rank. At the end of the game, we first get the score of the player, then we rank the score and have him refresh on the UI. You can see this. We can rank the latest score. First, the new score will be compared with each value in the previous array. Return the unit is greater than 1 value, it will take his place and return the index and score. Since the game can store a total of 6 scores, the following shows that if the comparison fails, it will determine whether the array length is more than 6, and choose whether to record the data. Then the function refresh the data on the UI and adjust their number and location. 6. Class and structure. All the enemies in the game, collectibles and various skills of the characters, etc., use the structure to classify various variables in an orderly manner. For example, this shows all the structure in the game, including scene information, save game structure, road, items, and character status. In addition, many props also adopt the relationship between children and parents. Just like some features in the road that are fixed to all roads, such as generating completely random item cards and enemies on all roads. So by binding these features to the parent class, all child of road can inherit this functionality, and then we just need to add differences in the child class. Seven playable on PC and a demo mobile version. The PC version has been shown before. In mobile version, the biggest difference is in UI and player controller, as most phones rely on screen touch. Through researching the number of buttons in the game, I have decided to present the mobile game to players in a horizontal interface. Referring to the player's posture of holding the phone horizontally, I place the directional control in the bottom left corner of the UI, and place the jumping, 1 skill, and 3 item bars in the bottom right corner of the UI for easy touch by the player. We add 2 new functions, on touch started and on to shended, through touch input in UE to control subsequent execution commands. For example, in this button, we use on touch started to control the command for slime to jump up and use on touchin to control the commands drop down. One no use spawn function. In this game we have no spawn for level generation, we use array utilize. As you can see, I first put together all the blueprints of the levels in the levels. And here is our player start. When we need the joints we have assembled, we will select one of them and set it for our subsequent level. As you can see here. First I select the level I want to get by getting all the serial numbers in the level and its ID, and then when the game is running, we get the level to set a new position, which is the distance from the previous position plus the length of the level. 2 score save, stored, and anti-cheating. The score section has already been shown upwards, and the score save is actually performed after the game is over, as you can see here. There are some checking and sorting. And then we use this function that we write to rank and store the scores that we get from the game. For anti-cheating, we take a method to counter the player's score. We set up a function called scoreCheck. If the player tampered with the game score, then the function will record the number items that player got, and then add up the scores come from that items. Finally detect whether the score is the same as the player's score. 3. Save game and load game. For save game, I use a parent class named saveGame to store the data in the game. We put the save and read functions in such a user widget. As we can see in the event diagram, we first use a Boolean value to determine whether the user is currently clicking on the widget to save or to read. If is store, it will display the data you saved on the UI. At this point, we put the data we need into the UI. You can see that the variables on the left are what we're going to store and display. Finally, we're going to store that data. The data will be stored in the file's text file in the UE directory. The loading process uses game instance as the middleman for data transfer. When we click on the Save UI interface page, first I will read the left data, and then store the data into BPGI at isGame instance. After loading the data, we will open another level. And the GM in this level will read the data in BPGI, which is the data we have saved. Just like these data. For software design pattern game instance and event dispatcher. Game instance has already been introduced above. In conclusion, the game uses two levels as the main screen and the content after starting the game, and game instance acts as an intermediary between the two levels to obtain the content of the main screen. Let the level read the content when loading the game, and then assign the content to the level after the game has started. This also takes advantage of the fact that game instance can exist across levels and be created automatically when the game starts. This also reduces the pressure on the game's memory. For the event dispatcher, I use the event dispatcher to detect if an enemy is dead. I first bind the monster subclass to a custom event dead. When we kill the monster, we call the dead event. The other side will receive the signal and execute the Boolean monster is dead to true. Through this method, we no longer need to use tick event to detect the monster's death all the time, but inform the result through event dispatcher, which saves a lot of game resources.